In this video we're going to look at conditional probabilities. Now, conditional probability is the probability that something occurs given that something else has previously occurred. So we use this line symbol here in statistics to represent conditional probability, and we would say this is the probability that the event A is going to occur given that B has occurred. Okay, so what's the probability that A is going to occur given that B has already occurred? So for example, what's the probability that you'll be late for college given that you've overslept? Have a look at a few examples here. So you can have a little think about these. What's the probability of being right-handed given that you're a girl? And what's the probability of being a girl given that you're right-handed? Have a little think about those two. Well, the probability of being right-handed is not really any different whether you're a girl or a boy, and it's around about 90%, so 0.9 would be the probability of being right-handed. And like I said, it doesn't matter if you're a girl or a boy. Probability of being a girl given that you're right-handed, well, it's approximately 50-50 boys and girls in the world, so doesn't actually matter if you're right-handed or not. The probability of being a girl is still around about 0.5. In the next two, we've got the probability that your car won't start given that the car has an empty petrol tank. Well, I think you'll agree that if you have no petrol, your car's not going to start. So I'm just going to mark that off as 0. So let's make it around about 1.0. What's the probability that your car has an empty petrol tank given that your car won't start? Well, just because your car won't start, there are other reasons why that may be the case. It may be that you're out of petrol. You could also have a flat battery or some other mechanical problem there. But I would say it's maybe, I don't know, 0.6, 0.7. Probability that it's because your petrol tank is empty. What's the probability that you're studying A-levels given that you're at Holy Cross? Well, we do have some students that just do GCSEs or BTECs, but the majority of students are studying A-levels, so that's quite high. Okay, I'm just going to put a guess there of 0.9. What about this last one? What's the probability that you're at Holy Cross given that you're studying A-levels? Well, a bit of a trick this one, I think, because just because you're studying A-levels doesn't mean that you're at Holy Cross. You could be studying A-levels at any college in any city around the world. So that's going to be a pretty low probability, I would say, something like that. Okay, so that's just a few fun examples there. In the next one, we have a Venn diagram, so you should be used to this now. And we have people that prefer apples or bananas, and some like them both. So we have 26 people here that like apples. We have 18 people that like bananas, 2 people that don't like either, and 14 that like both. And we want to work out what's the probability that they like apples given that they like bananas. Well, with a Venn diagram, what we're going to do here is we're going to restrict the sample space. Okay, so if we restrict it to just the probability of B, so we're just looking inside the circle for B, inside this event. What's the probability that A occurs within this side event, within this this event of B? Well, you can see there's 14 that occur in A that are occurring in B. So we would write this as 14 out of 18. So just the sum of these two. So the conditional probability, that bit there, we've restricted the sample space to just that area inside B. We're saying what is the probability of A occurring inside B? Okay, if we do it the other way, we look at the probability of somebody liking bananas given that they like apples. Well, this time we're going to restrict the sample space to just inside of A. Okay, so we're just looking inside A here. And what's the probability of somebody liking bananas? Well, there's 14 that like bananas inside here. So it'll be 14 this time out of 26. Okay, there's a couple more here. What's the probability of somebody liking bananas given that they don't like apples? Okay, well, you need to think about the probability. Where is this this area not A? Well, not A is on the outside of A. Okay, so everything on the outside of A. So we're actually restricting the sample space. I'm just going to shade it here to this area here. Okay. So the probability that like bananas inside of this area, well, there's only 4 that like bananas inside this area. So this one would be 4 out of a total of 6. So this 4 and this 2 combine to restrict the sample space there. And you could simplify these fractions. I've not done it here, but you could do that. And the last one, what's the probability of not liking apples given that you like apples or bananas or both? That's what the union represents. So if I just get rid of these shading, and we'll shade the new restricted sample space. Okay, so this time we're looking at the union of A and B. Let's do this in blue. So we're going to shade all of this region here. That's the restricted sample space. So what's the probability of not liking A? Where is not A inside that restricted sample space? Well, not A is on the outside of A, so that's just this 4 that lies within the restricted sample space. So this one's going to be 4 out of a total of 12 and 14 and 4 is 30. Okay, so that's conditional probability with Venn diagrams. Here we have another Venn diagram, but this time we've got 3 events, and these represent students that take physics or chemistry or biology, or a combination of all 3. So when you're doing this, what we're trying to do is to look at the number of students that are taking all 3, and we start in the middle. So 15 take all 3, so I'm going to put 15 in the middle there. Okay, we can now look at work our way up. So 24 take biology and physics. So biology, physics, so the union between those 2. Okay, so if that's 24, then that means that must be 9. And the next one, 37, take chemistry and biology. So chemistry and biology is 37. We've already got 15 of them, take all 3. So that means that we must have 22 that only take biology and chemistry. Okay, we've got 37 that take them both, but 15 take physics as well. So 22 in that little area there. 62 take physics and chemistry. So looking at the union between physics and chemistry, if that's 62, we've got 15, which leaves 47. Okay, and you can complete the rest of these. Hopefully you guys can do this, and you should agree with my values here. I'll double check just in case I've gone wrong. And then finally, once you've filled out those 3 circles, because we've got 200 students, if you add up all of these numbers inside the circles and take it away from 200, you're left with 43. So that's the first step there, is just to fill out that Venn diagram. And now we can start looking at some conditional probabilities. So we're looking at the probability of taking biology given that you take chemistry. Is there a link there? Well, chemistry, we're restricting the sample space to just inside the circle C, and we've got 37 that take biology within that restricted sample space. So this one's going to be 37 out of, if you add up those numbers, people doing chemistry is 85, so it's 37 out of 85. Probability of doing chemistry given that you do physics. Okay, so we're restricting the sample space to just inside P here, and we've got, what's that, 72. Sorry, that's not 62, I should say. So 62 take physics and chemistry, and we want to know how many take chemistry given that they take physics. Okay, so given that they take physics, so that's a total of 108 take physics. So you can start off by writing down that denominator, and then we've got 62 there that take both. Okay, so 62 take chemistry given that they take physics. I'll do the next one, and then I'm going to give you a couple of minutes to do the last two. So what's the probability of taking all three given that you take physics? Well, again, we just restrict the sample space to inside the circle P, inside the event P, and we've got 15 that take all three out of all of those that do physics, which again is 108. Okay, I'm just going to give you a minute to try the next two. Okay, so the probability that they take chemistry given that they take physics and biology. So here we're restricting the sample space to the intersection between physics and biology. So there's a total of 24 there. That's what's going to go on the bottom. And the probability that they do chemistry within that area, well, there's 15 inside that that intersection. So it'd be 15 out of 24. And the last one, the probability that they take biology given that they take physics or chemistry. So this time we're looking at the union between physics and chemistry. So all of these numbers here, so all of that area, and if you add those up, you get hopefully the same answer as me, 131. And probability that they take biology inside that union, well, it's just the sum of these three numbers here that are in biology that are also within P and C. So 9, 15 and 22 adds up to 46. Okay, so that's an example with a Venn diagram with 3 events. Right, why don't you take a go at exercise 2C, and then we'll move on with some more conditional probability after. So we're going to continue now with conditional probabilities from tables, and we're going to look at a two-way table to start with. And in this example we have a school with 75 students in year 12, and out of these students 25 study only the humanities subjects and 37 study only the science subjects. 11 study both of them. And we need to start off in part A just by drawing a two-way table to show this information. So across the top here, let's just get my pen, I'm going to write humanities or not humanities, and we're going to have a total. And then down the side, this is going to represent students that study the sciences, or they don't study the sciences. I'm just using this not symbol to represent not the sciences, and again we'll have a total there. And we can put some numbers in. So starting off with sciences and humanities, students that study both, well, there's 11 that study both of them, so I'm going to put 11 in that cell. We have 25 that study only the humanities. So they study the humanities but not the sciences, so that's going to go in here. So humanities but not the sciences. We have 37 that study only the sciences, so sciences but not the humanities. That's going to go in there. Okay, now we can start filling out the rest of this this table. So if I go across here, we have a total. So 11 and 37, put a total of 48 there, and we can go down this first column here. 11 and 25 is 36. And we also know that there's a total of 75 students, so that's going to go in this cell here. So 75 students in total, and we can fill out the rest here. So 48 plus something will give me 75. So students that study the sciences and don't study the sciences add up to the total number of students. So we're going to have a value of 27 here. And if I go across the bottom row, we have 36 that study humanities. How many do not study humanities? Well, if there's a total of 75, then that's going to give me a value of 39 in this cell. And then either vertically or horizontally, we can work out this value, and that comes to 2. Okay, so there's our two-way table. Now we can have a look at, that was part A. Part B, we want the probability that a student doesn't study the sciences and they don't study the humanities. So not sciences and not humanities. So that's going to be this number here. So probability of not sciences and not humanities is 2 out of a total of 75. That's not a conditional probability as such, that's just a probability from this table. Now we have 2 conditional probability questions. The probability that a student studies the sciences given that they study the humanities. Well, what we're going to do here is we're going to restrict the sample space to just humanities. So we're just looking at this part of our two-way table, the students that study just the humanities. And out of that reduced sample space, how many study the sciences? Well, that's going to be 11 out of a total of 36. Okay, got one more. Squeeze it on the bottom here. So we want the probability that they study humanities given that they don't study the sciences. Okay, so this time we'll do this one in red. We're restricting our sample space to not sciences, and that means we're looking at this part of our two-way table. So students that don't study the sciences, that either do study the humanities or they don't study humanities. We want to know what's the probability that they do study humanities given that they don't study the sciences. So that's 25 out of a total of 27. Okay, hopefully that made sense. We can also have a look at sample space diagrams when we have spinners, and we've got 2 fair spinners, so that means the probability is the same of landing on any face. So 2 spinners, each have got 4 faces numbered 1 to 4, and the 2 spinners are thrown together and the sum of the numbers is recorded. Okay, so I'm just going to go across the top here, and I'm going to say this is representing spinner 1. So that can land on 1, 2, 3 or 4. And then down the side, this is spinner 2. And again, that could have numbers 1, 2, 3 and 4. Now, if we're recording the sum of these scores, then we're going to get these values. So 1 plus 1 is 2, 2 plus 1 is 3, and so on. And it's quite easy to fill this out. Like so. Okay. Now, it says given that at least one spinner lands on a 3. Okay. Creating the probability here. Find the probability that the spinners indicate a sum of 5. So what's the probability that the sum is 5 given that one of the spinners or both of them land on a 3? So what I can do here is to restrict my sample space. This shows you the sample space of this problem, and we're going to restrict it to either spinner 1 landing on a 3 or spinner 2 landing on a 3. Okay, so you can see we have 1, 2, 3, 4, 5, 6, 7 different ways that either spinner 1 or 2 or both can land on a 3. Okay, so find the probability that the sum is exactly 5. Well, it's just that one or that one where the sum is 5. So this probability is going to be 2 successful outcomes out of a total of 7. 7 possible combinations where 1 or 2 or both of them land on a 3. Okay, so that was that question. Right, there's a couple of questions here that you can try. Whoever's looking at this video can just pause it to give you some time to do these questions, and then we can have a look at the answers in a moment. So you can pause the video at some point, and then I'll show you the answers. Okay. You probably need, I would say, a good 10 minutes, I would say, to do these two questions. 10 maybe 12 minutes at most.